All right, so y'all should have already been working on 512, but just to go back and give you some examples here. So given the point P53, okay, and T, the transformation of xy is x plus 2 and y plus 2, what are the coordinates of T, P? So what are the coordinates of transformation applied to P? So all we have to do here, this is a pretty straightforward deal. So if you have on a graph, let's see here, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, so originally we had the point 1, 2, 3, 4, 5, up 3. So we had 5, 3. And now we're going to take this transformation and apply it to it where we add 2 to the x. So that would mean I move 2 to the right. Okay, you don't have to draw the arrows when you do this on your paper. I'm just kind of doing it to show you what's happening here. So, and then we also are going to add 2 to the y values, which means we go up 2, right? And so this is our pre-image, and this is our image. Okay, that's where it moved to. Okay, now, so that is the new point being 7, 5, comma 5. All right, so that is a transformation. Okay, again, a translation specifically is the transformation that's happening. Transformation is a movement of some kind. Translation means you just shifted it. We've had that conversation. Reflection means you flip it, right? Left, right, up, down, over a line or whatever. And then, of course, the last one that we're really concerned about is a rotation. Now, we may also talk about dilation, though we will talk about dilation some. But for our focus here is going to be on those other three. It's going to be on rotations, reflections, and translations. Okay? So, it is worth noting that you could figure out the distance it moved. The distance would be, your right triangle here, if you think about it. The distance between those points would be Pythagorean theorem. You could be asked at some point to go back and calculate that, so just be aware. But anyway, we have answered the question. We have figured out the coordinates of TP, which is this. All right, so let's look at example 2 here. Given triangle ABC, which is at 5, 2, 3, 5, and 2, 2, and then the transformation is x, negative y, what would the coordinates and the vertices of that translation or transformation be? Okay, what kind of transformation is it? So, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's see, 5, 2. 5, 2 is there. 3, 5. And 2, 2. Okay, so that's a triangle. And we want to do x, negative y. So my x's are not going to change, but my y values are. Okay, and that means that we're going to have each of these points, we're going to apply that rule to it. So that means that the first point is going to become 5, negative 2, because we're making the y value negative, but the x value doesn't change. So 5, negative 2. Then the next one is going to be 3, negative 5. And the last one is going to be 2, negative 2. Okay, so when I graph those, let's see what it looks like. So we have 5, negative 2. We have 3, negative 5. And we have 2, negative 2. Okay, so that is a reflection. The reflection over the x-axis. So notice, this is worth noting, when you reflect over the x-axis, the y value becomes the opposite, becomes the negative version of whatever it was. Okay, but the x value doesn't change. So based on that, so we don't have an example of it, but guess what happens if you had a y-axis reflection? The y part wouldn't change, but the x would be negative. So when you throw a negative in front of it, that transformation that happens becomes a reflection. So negatives are what causes that. Translations are when we added or subtracted a number, right, to the x or y. Reflection is when you throw a negative in front. Okay? Now, sorry about that. Let's take a look at this next one. Given the transformation of t 5, -3, and the points -2, 1, and 4, 1, show that the transformation of the translation is isometric. We're not going to do the calculations on length and PQ and P prime, Q prime. We're just going to talk about it. So we're going to go 5 to the right and 3 down. Now, obviously, I can't show you that very well here, but I'll show you with P, right? So -2, we're going to go 5 to the right, 1, 2, 3, 4, 5, and then down 3, 1, 2, 3. So that's my new P. That's P prime, okay? Sometimes you'll have prime notation instead of image and pre-image. Now, same thing would happen with Q. 1, 2, 3, 4, 5, down 1, 2, 3. That's the best I can do with that. And that's not even close. And it's basically there. Okay? All right, so the idea here is that we did a translation and nothing else. We didn't do any kind of dilation or anything. So if you were to calculate the length of those two lines, they would be identical. Okay? It's just a straight line, so it's just 5. It's 1, 2, 3, 4, 5, 6 units long. So that's all you're going to see there. All right. Given t is -6, 2, x, y, and it's -6 and +2, state the translation that would yield the identity transformation. So if we're doing double transformations here, so like we have t of h and k, and then t of -6, 2 of x and y. All right, so what would that look like? Well, if it's on the inside, that's the first transformation you apply, and then you can apply whatever's on the outside. So what does this look like? Okay, well, since this is a translation, right, both of these are translations, this is going to look like this. Each point will be like this: x -6 plus h, comma, and then y plus 2 plus k, right? You simply apply the first one and then apply the second one. Okay? That's how that works. You work your way from the inside to the outside. Now, they want the identity property, all right? The identity transformation. Identity means h needs to be something that cancels out the -6. So guess what? It's going to be x -6 plus 6. Okay? Which means that h is 6. And then y needs to be something to cancel out the 2. So y plus 2 minus 2. Okay? Which means that k is -2. K equals -2. All right? So your h and k here, your h and k is 6, -2. That's only because you're doing the identity transformation, which means whatever you applied, you're then basically trying to undo to try and get it back to being just h and k. Okay? All right, so we'll stop with those examples there. Again, there's a lot more that we can do with this. There's a lot more variations of this. We really didn't talk about much about rotations. But the truth with rotations is this. You don't really want to try to memorize a rule for rotations, right? The plus and minus with the translations is pretty easy, and the positives and negatives with the reflections is also pretty easy. But the rules for rotations get very, very hard to memorize. So you don't want to try and do that. Basically, what you want to do is just learn how to rotate around a point. We'll do some more practice with that in 5, 5, 2, 1, and 5, 2, 2. Okay? All right, good deal.